Alright, so here is the test review. So number one says to find the inverse of the relation, then determine if the inverse is a function. Alright, so all you have to do for this one is just simply switch the x and the y values. So 6, 3 becomes 3, 6. 8, 4 is 4, 8. 10, 5 is 5, 10. Now this is going to be my inverse right here. Now we're going to look at the x values to see if they repeat, and we notice they don't. So is it a function? Yes. Alright, for the next one we do the same thing. We just switch the x and y to get the inverse. This time when we check our inverse, we see that the 1's repeat. So this one is not a function for the inverse. Alright, for number 2 and 3 it says find the inverse of each equation. Then graph each equation and its inverse, determine if the inverse equation is a function. Okay, so for number 2, first thing I'm going to do is I'm going to switch the x and y. Notice I didn't move any numbers, just the x and y variables, that's it. So to solve this, we do PEMDAS backwards, so we're going to add 1 to both sides. That gives me x plus 1 equals 2y squared. After addition or subtraction, we multiply or divide. So in this case, we're going to divide by 2. So 1/2 x plus 1/2 equals 2y squared. So to get rid of the square, the exponent, we take the square root. Don't forget to put plus or minus. So in this case, the inverse of y is equal to plus or minus the square root 1/2 x plus 1/2. Alright, now to graph this one, I'm just going to make a quick table here. Here's x, y. I'm going to use -2, -1, 0, 1, and 2. And just to kind of show you the work that I'm doing behind this, I'm just going to put in a calculator to see what I'm doing. So we have 2 parentheses. For x, I'm going to first put -2, close parentheses squared, and then -1, and you'll see I get a 7. So now I'm going to change that to -1, and I would just keep doing this. And so we have 7, 1, -1. If you kept going, you would get 1 and 7 again. Alright, so from here, we can graph this now. So 0, -1, 1, 1, 2, 7. Let me do the other side as well. We make our graph. And there we go. Now, to get the inverse, we're just simply going to switch x and y. So the y's become the x's, and the x's become the y's. And now we're going to grab this. And try to graph it the best you can. And there it is. So really quickly, if I just do a vertical line test, you'll notice it hits twice, once there and once there. So in this case, is it a function? The answer is no, it is not a function. All right, for number 3, this is a linear line. So same concept, we're going to solve it for y when we switch x and y first. So to find the inverse, we switch x and y. And then we're going to do PEMDAS backwards, so we add first. So we're going to add the 4. So x plus 4 is equal to 2y. And then we divide everything by 2 to isolate the y. And then we get that the inverse of y is equal to 1/2 x plus 2. Now for this one here, I'm not actually going to make a table. This is a line, so we know that this is the y-intercept. So this is where we begin on the y-axis, so -4, 1, 2, 3, 4. And then this right here is my slope. So we do rise over run, so 2 over 1. So positive 2 is up 2, positive 1 is right 1. So from this y-intercept, up 2, right 1. And there is our original function. And now for the inverse, you can take these values and switch them, or you can graph it just like we did this one. So the y-intercept here is going to be positive 2. My slope is positive 1 over 2, so up 1, right 2. And then backwards, down 1, left 2. Make our graph. And this one we can see that if we did a vertical line through here, no matter how many times we did it on the inverse, it would only hit once. So yes, this one is a function. All right, so for number 4, pretty easy. We're just going to take these points, put them as our original function, and then find the inverse by switching x and y, and then plot our points. All right, so we have -3, -3, -3, 4, 0, 5, and 2, 2. So my inverse will be switch x and y. All right, so -3, -3. 1, 2, 3, 4, -3, 5, 0, and 2, 2. And there is our inverse. All right, for the next ones here, it says, find the inverse of the following equations algebraically. Okay, so again, we're going to switch x and y, and then we're going to solve for y. So here, this is actually y, so we're going to do x equals 1/3 y minus 8. So add or subtract first. So we're going to add the 8. So we get x plus 8 is equal to 1/3 y. And then you can divide by 1/3, but I like to multiply by the reciprocal, so I multiply both sides by 1/3 flipped over, which is 3. And 3 times x is 3x. 3 times 8 is positive 24. And 3 times 1/3 is just y. So the inverse of y is 3x plus 24. All right, for number 6, same process. First, we're going to switch x and y. First, we add or subtract, so we're going to subtract the 7. So x minus 7 equals to 5y. Multiply or divide, so we're going to divide by this 5 here. And so 5 divided by 5 is just y, so the inverse of y is equal to 1/5 x minus 7/5. All right, on to number 7. So for number 7, again, to find the inverse, we switch x and y. All right, so first thing we're going to do, we're going to add 8 to the other side. So we get x plus 8 equals 2 times y plus 1 squared. So we just did addition or subtraction. Now we're going to do multiplication or division. So we're going to divide everything by 2. So 1/2 of x plus 4 equals 2 parentheses y plus 1 squared. To get rid of the square, we take the square root and we put plus or minus. Plus or minus the square root of 1/2 x plus 4 is equal to y plus 1. And the last step we do to solve the inverse is subtract 1 from both sides. So at this point here, we get the inverse of y is equal to plus or minus. And you can put the -1 in front or in the back, it's your choice. You can put plus or minus the square root of 1/2 x plus 4 on the outside minus 1, or you could put the -1 in the front. That is going to be your choice right there. So that answer is acceptable, and if you wanted to do it the other way, let's just put it underneath. The inverse of y equals -1 plus or minus the square root of 1/2 x plus 4. So both answers are correct. All right, so now we're on to, it says to use the graph of f of x and g of x below to find the following. All right, so just in case you have forgotten, make sure you identify which graph is which. This is f of x, and this is g of x. And again, to kind of help you figure these out, just remember f of x is equal to y, and this could be f, g, h, it could be whatever letter, but whatever number is here is x, so if I give you x, I want you to find y. If I give you y, I want you to find x. Okay, so just make sure you can tell the difference. So the first one says f of 0, so if x is 0, we're looking at f graph, so 0, the y value is 8. For f of 3, so x again is 3, we go down, we hit the graph, and the y value is negative 1. For f of 5, again the f graph, we go to x is 5, we go to the graph where it hits, and the y value is 3. This one now says g of negative 2, so g is right here, so x is negative 2. We go down, we hit right here, what's the y value? Negative 2. G of 2, so g graph again, 2 is, it already hits there, so x value is, or y value is 0. G of 0 is right here, we go up, it hits y value of 2. Now this is a composition, so g of 0, so we go g of 0, we know g of 0 is 2. So now we're looking for f of 2. So f of 2 is already here, so it is 0. So f of g of 1, the number's on the inside, so we look for g of 1. G of 1 is positive 1. So now we're doing f of 1. And f of 1 is y value is 4. So now I'm just going to do them. So g of 2 is 0. So f of 0 is 8. So f of g of negative 1, so g of negative 1 is positive 1. So now we do f of 1, which is 4. G of negative 2 is negative 2. But when we go to f of negative 2, you'll notice that it does not exist. It's not there. It's not a part of the graph. And it even says from 0 to 5, and negative 2 doesn't fall in that domain right there. All right. Now we're going to do f of 3. So that's in the inside, f of 3, which is negative 1 for y. So now we do g of negative 1, and our y value is 1. F of 2, because that's where it starts, is 0. So now we're going to do g of 0, which is 2. F of 1, which is 4. So now we do g of 4. The y value here is 4. F of 0 is 8. G of 8 does not exist because it even stops at 4. All right, now these ones right here, careful. When does f of x equal 4? So 4 is a y value, just like the rest of these are all y values. And make sure you pay attention to which function they give you. So this is saying that on the f function, when y is 4, what is x? So we go to f of x, draw a horizontal line through 4, and we can see it hits only this point, and the x value is 1. So x equals 1. For the next one, it says, when does f of x equal 0? So we're going to go for y is 0 on the f graph. When I draw my line through, you can see it hits at 2 points, x equals 2 and x equals 4. For my next one, when does g of x equal 1? So now we're looking at the g graph. So when does it equal 1? So we can say x equals 1, or sorry, negative 1, positive 1, and 3. So if you want to do it like that, you can as well. And then for the last one, it says, when does g of x equal 4? G graph hits the point right there, x equals 4. All right, that's how you do these compositions off of a graph. All right, for 27, it says let f of x equal x plus 3 and g of x equal negative x squared plus 4. Find the indicated value. Okay, so this one, pay attention to where the number is. Like on the first one, g of f of 6. So our first number given is 6, and that's inside. So what we're going to do first is we're going to plug the 6 into the f function. So we have f of 6. So this is going to be this function right here. So x plus 3. So x plus 3. So 6 plus 3 is 9. All right, and now we're going we're going to take this 9 and plug it into g, so it's going to be g of 9. So right here, negative parentheses 9 close parentheses squared plus 4. So negative x squared plus 4. This one you can type in a calculator, but negative 81 plus 4 is negative 77. So g of f of 6 is negative 77. All right, on to the next one. So this one, you're not given a number, you're given a variable. So now we're going to take g of x and we're going to plug it into the f function. So into the f function, g of x is negative x squared plus 4. So this is how this one looks right here. We're going to write the f function, so x plus 3. So this is x plus 3. Now this goes into the parentheses here, so we have negative x squared plus 4. And you'll notice the parentheses are not necessary, so we have negative x squared plus 4 plus 3. And then last, negative x squared, 4 plus 3, we can combine these two, which is going to give us 7. So we now know that f of g of x is equal to negative x squared plus 7. All right, and the last one, we have g of f of x is equal to negative 21. So for this one, we're going to take the f function and plug it into the g function, and then we're going to set it equal to negative 21. So let's start with writing the g function. So the g function is negative. This is x squared plus 4 equals negative 21. So negative x squared plus 4. Now we're going to take the f function of x plus 3 and we're going to plug it right in here for x. And then now we're going to just solve this using PEMDAS backwards. So add or subtract. So we're going to subtract 4 from both sides. And we get negative parentheses x plus 3 squared equals negative 25. Multiply, divide. So we're going to divide by this negative 1 here. So now we get x plus 3 squared equals to 25. Now we do our exponent. So to get rid of the square, we take the square root. Don't forget to put your plus or minus. So x plus 3 equals plus or minus 5. So at this point here, since we do have 2, we're going to do, let's see what I do right here. X plus 3 equals 5, and x plus 3 equals negative 5. So we should come up with 2 solutions at this point. So for the first one, we subtract 3 from both sides, and 5 minus 3 is 2, so x equals to 2. The second one, we subtract 3 as well, and negative 5 minus 3 is going to be negative 8, and our second answer is negative 8. So 2 comma negative 8 are our solutions. All right, on to 28. It says let g of x equal x minus 4 and h of x equal x minus 2 over 3. Find the indicated values. Okay, so the first one for letter A, it says to find g of h of 8. So we're going to start with this h of 8 right here because we have the 8 and we're going to plug it into the h function. So h is x minus 2 over 3, so x, which is 8, minus 2 over 3. So 8 minus 2 is 6, divided by 3 is 2. So now we're going to take 2 and plug it into the g function. So we're going to do g of 2. So g is x, which is 2, minus 4, which is going to be negative 2 is our answer. All right, for the next one, h of g of 9. So we're going to take 9 and plug it into the g function. So g of 9. So right here we have x minus 4, and 9 goes in that place, which is going to give us 5. And then for right here, we're going to take 5 and we're going to plug it into the h function. So we're doing h of 5. So we have x minus 2 over 3. So 5 minus 2 over 3. 3 over 3 is 1. And then for the last one, we're going to plug it into itself twice. So we're going to take negative 4 and plug it into h. So we have negative 4 minus 2. So x minus 2 over 3. So negative 4 minus 2 is negative 6. Divided by 3 is negative 2. And now we're going to do h of negative 2. So again, x minus 2 over 3. The negative 2 goes in there. So we have negative 4 over 3, which is negative 4/3. All right, 29, it says our f and g inverses. So what you want to do here, when it gives you a choice, all you got to do is just pick one of them, or what I would do is pick one of them, switch x and y, solve it, and if they match the other equation that you didn't solve, then they're inverses. So let me show you what that looks like. So I'm going to pick this one right here. So this is y and this is x. I'm going to switch those. X equals 3y minus 15. And then all I'm going to do here is just solve for y. So PEMDAS backwards. So add or subtract first. So we're adding 15. X plus 15 is equal to 3y. And then we divide both sides by 3. And we get the inverse of y is equal to 1/3 x plus 5. So I'm comparing this to this. And if you'll notice, they're the exact same. So yes, they are inverses. And here's the work to support the answer. All right, for the second one, we'll do the same thing. I'll solve this one just because it seems easier. So let's switch x and y. So x equals 3y plus 4. So addition or subtraction. So we're subtracting 4. So x minus 4 is equal to 3y. Multiply, divide. So we're going to divide both sides by 3. And now we get the inverse of y is 1/3 x minus 4/3. So when I compare this to this, I notice they're not the same. So no, they are not inverses. All right, now we're on to 31 and 32. So this one says to perform the indicated operation. So the first one says to take g of x and plug it into the f function. So I'm going to go and write this here. F of g of x is x squared minus 2. Now I'm going to write the f function x plus 5. So x plus 5. Again, remember, this goes into the parentheses. So we're going to try to put x squared minus 2 in for x. Now you'll notice these parentheses are not necessary. So we have x squared minus 2 plus 5. And hopefully you can see you can combine negative 2 and 5. So we get x squared plus 3. So f of g of x equals to x squared plus 3. All right, now we're on to the second one. This one says f of g of x. So again, we're going to take the g function and plug it into the f function. So f of the g function is the square root of x plus 1. So I'm going to write the f function. So x squared, so x squared minus 1. So we have the square root of x plus 1 squared minus 1. Now we know the square root and the square root inverses, so they will cancel each other out, leaving me with x plus 1, bring down my minus 1. And here I combine 1 minus 1, which is going to just leave me f of g of x is equal to x. Now, just in case you're curious about inverses with compositions, so if I asked you whether these were inverses or not, this one right here, x squared plus 3, since it did not simplify down to an x, these would not be inverses. But since this one right here, where I did the composition, simplified to an x, number 32, that means these two functions, f of x and g of x, are actually inverses of each other. All right, let's take a look at the next parts. All right, so for 33 through 34, let's go ahead and do these real quick. So we're using these ordered pair to figure it out. So fog of 6 is really just f of g of 6. And since we have g of 6 in the inside, we're going to start there first. So g of 6, so we go to the g function and we find x is 6, and then we find the y value. So g function, x is 6, y is 2. So now we're going to look for f of 2. F function, x is 2, the y value is 4. For the second one, f of g of negative 3, so we're going to start with the inside, g of negative 3. So we have the g function, x is negative 3, y is 5. Now we're going to go and plug 5 into the f function, so f of 5, so f function, x is 5, y is negative 7, and there's my solution. All right, for 35 through 40, given f of x, g of x, h of x, find the composite functions, okay? So for the first one, again, like I said previously, this is just f of g of negative 2. So we start with the inside, we're going to plug negative 2 into g. So my g function is x squared minus 4. And then for x, we plug negative 2. So you might want to type this in the calculator if you can't do it, but negative 2 squared is 4. 4 minus 4 is 0. All right, from here, we're going to now plug 0 into f. So f is 2x minus 5, so 2x minus 5, we plug in the 0. 2 times 0 is 0, 0 minus 5 is negative 5. All right, on to 36. So for 36, we're going to plug the 1/2 into the h first. And you can do 0.5, that's your choice. So we have negative 3 times x. In for x goes 1/2, which gives me negative 3 halves. So now we're going to take negative 3 halves and plug it into the g function. So now we have g of negative 3 halves. So we go find the g function. So x squared minus 4. So x squared minus 4. And we're going to plug negative 3 halves into there. So negative 3 squared is 9. 2 squared is 4 minus 4. And if you work this out, you do get negative 7 over 4, or you can get negative 1.75. And then for the last one, h of f of 4, for these ones at the top at least, we start with f of 4 because that's where the number is. So we go to the f function, we plug in 4, so 2x minus 5, 2x minus 5. We plug the 4 in for x. 2 times 4 is 8. 8 minus 5 is 3. So now we're going to do h of 3. So h function, negative 3x. So negative 3x, we plug in the 3. Negative 3 times 3 is negative 9. All right, down to the last 3 problems here. So the first one is actually f of h of x. So we're going to plug h of x into f. So h of x is negative 3x. So the f function is 2x minus 5, so 2x minus 5, and we plug negative 3x in for the x. 2 times negative 3x is negative 6x minus 5, and you're not setting it equal to 0 or any number, so negative 6x minus 5 is your expression. All right, for the next one, we're going to take g of x and plug it into f. So g of x is x squared minus 4. Now we're going to write the f function, so 2x minus 5, so 2x minus 5. And we're going to plug in that x squared minus 4 for it. So we're going to distribute. 2 times x squared is 2x squared. 2 times negative 4 is negative 8 minus 5. And 2x squared, negative 8 minus 5 is negative 13. All right, and now we're down to the last problem. So we're going to plug h of x into g. So h of x is negative 3x. The g function is x squared minus 4. So let's plug in this negative 3x. So we square each one. Negative 3 squared is 9. X squared is x squared. And then minus 4, we can't combine them because they're unlike terms. So that is my final answer.